I'd like to take this opportunity and to discuss part C, number 5 in the sample midterm. Okay, so this is the question about refinancing. All right, 10 years ago, Reem and Forsan took out a $150,000 mortgage to buy their new house. The mortgage was a 20-year, 10% mortgage with annual payments. Today, their bank offers similar mortgages at 8% interest. However, when the young couple went to the bank to ask about the possibility of refinancing, the remainder of their mortgage was a 10%, was a 10-year, 8% mortgage. They were told that the bank actually charges a $15,000 extra fee for the refinancing. So part A, is asking, should they still refinance? And part B is asking, what's the maximum extra fee they are willing to pay in order to refinance? And part C is asking, use the data table functionality to illustrate how their decision would change as the extra fee and interest rate on new mortgage change. Okay, and it's actually very specific. The extra fees would actually range from 8,000 to 15,000 in increments of 1,000. And the mortgage rate on the new mortgage would actually range from 7% to 10.5% in increments of 0.5%. All right. So I'm going to focus on part C here because I have the video for part A and B. All right. So in order for me to actually, do the data table, I need to actually, set up these two, inputs. So right now, the extra fee is 15,000, and the new mortgage rate is actually 8%. Okay, so we know that as a rule of thumb, you want to actually consider refinancing if the drop in the mortgage rate is actually more than or at least 2%. All right, so in this case, it's actually dropping from 10 to 8%. So that means they are actually considering this possibility of refinancing. All right, so now step number 2. Okay, I'm going to actually use these two inputs along with other inputs. Let's look at their refinancing decision. Okay, so I need to actually model the refinancing decision. All right, so step number 1, oops, I should say, first of all, let's look at how much they owe on the old mortgage. So in order for us to find out that, let's look at old mortgage monthly payment. All right, so let's actually go ahead and calculate how much they were paying on the old mortgage. So that's going to be the payment function here. It's annuity. The old mortgage has 10% rate. Okay, and the number period here is 20. It was a 20-year mortgage. The present value is the house price, 150,000, and the future value is 0. And so, whoops, what did I do here? 10%. Okay, not 10%. All right, so $17,618.94 per, actually not per month, but per year. Okay, it's the annual payments. All right, and let's look at how much they owe at the end, after 10 years. All right, or in 10 years. Okay, so they took out this mortgage 10 years ago. So this is really how much they owe today. All right, so this is actually looking for the future value of this following annuity. The rate is 10%, and they have paid 10 years. Each payment is this, and the present value is the loan, which is the house price. Okay, so this is the $108,260.78. Okay, so this is how much they owe. So how much they borrow in the new mortgage? Well, they need to actually borrow $15,000 more because they need to actually pay the $15,000 extra fee they also need to pay how much they owe on the old mortgage. So the total is going to be 15,000 plus this negative, or I should say minus this negative 108. So that's how much they're going to borrow. All right. And how much they get today? Well, how much they're going to get is nothing but how much they borrow minus the 15,000. All right. So they're going to get this 108,260.78. And that's exactly how much they owe on the old mortgage. All right. And now I'm going to find out, what the annual payment on the new mortgage. Okay, so the new mortgage is going to have, all right, so I'm going to look at the rate, which is 8% new mortgage rate, and it's for 10 years. And how much they borrow? Well, they borrow this much, and the future about is 0. So that's how much they're going to pay on the new mortgage. All right. And so now I'm going to look at the annual rate on the new mortgage. I should say, the IRR or the annual rate, that's actually the same thing in this case. So let me actually look at this timeline here. So this is for today. This is a 1 year from today, and we have 10 years for the new mortgage. And we have the cash flow per period. So this is actually how much they're going to pay every year. And I'm going to lock this down here. That's 18,369. And these numbers are a little messed up. So let me just clean up the mess. Okay. And this actually is, the amount they're going to get today. And so that's the 108,260. All right. So the IRR of this mortgage cash flow is going to be the IRR function applied to these cash flows. Okay. So that is 11%, which is actually 10.98. All right. So I can actually convert that into APR and eventually EAR. Now, this is annual payment, so it's actually the same thing. Okay. I'm doing the effective function here. I take the APR, I put down 1. So that's the new mortgage rate. All right. So this is the new mortgage EAR. All right. So now I can actually look at the decision here. The decision here is, all right, I'm going to use the if function here. And if the new mortgage rate is greater than the old mortgage rate, which is 10%, then we say the old mortgage is actually cheaper. So you do not refinance. Okay, you just stay with the old mortgage. On the other hand, if the new mortgage rate is actually less than the old mortgage rate, then you're going to do the refinancing because the new mortgage is actually cheaper. All right, so that is our decision here. All right, so this actually completes my first 2 steps here. And let's just verify that there's a link. So let's say, how about I change this to 8,000? If the exit fee is 8,000, everything changes. And yes, the conclusion changes. Okay, so that's good. All right, so let me change it back to 15,000. And let's say the rate actually changes, from 10% to 6 instead of 8. Then the new mortgage rate is actually 8.84. And that's actually a lot cheaper. So yes, you're going to do refinancing. Okay, so yes, there's a link. So we actually just verify the link. So now step number 3, I'm going to actually, set up and build the data table. All right, so I'm going to set up the, according to the question, we need to actually use the exit fee, in the row. All right. Well, it doesn't say you have to do this in a row. So I'm going to set up the exit fee in a row. You can set up the exit fee in a column. It doesn't matter. All right. So exit fee goes from 8,000 in increments of 1,000 all the way to 15,000. Okay. So 8, 9, 10, 11, 12, 13, 14, 15. All right. And then I'm going to look at the new mortgage rate. And this actually goes from 7 to 7.5. All right, increments of 50 basis points all the way to 10.5. Okay, so 10.5. All right, and now this is actually the new mortgage rate in column. All right, so now I'm going to use this top left corner cell. That's my decision here, and I'm ready for the data table. So I'm going to highlight everything here, go to data, what if analysis, data table. My row input cell is the exit fee. So I use this number when I actually calculated my decision. All right, so I'm going to use the C3. My column input cell is the new mortgage rate. That's the rate I use when I actually model the decision. All right, so let's click OK. And we have all the decisions here. All right, so do not refinance versus refinance for different combinations of, the exit fee and the new mortgage rate. All right, so if you look at, this part C here, if the new mortgage rate is actually 8%, if you look at this particular, row here, you see that when the exit fee is 9,000, you want to do refinancing. When the exit fee is 10,000, you don't want to do refinancing. So the maximum exit fee at which you're willing to do the refinancing is actually between 9,000 and 10,000. And you know from part B that the answer is 9,900 or something. Okay. So you can also use the data table if you want to actually find out the exact answer. But I don't have time for that particular data table. Basically, what you need to do is to use finer grids so that you're actually increasing this by let's say initially maybe $50 each time. You narrow it down, and then by another $20 each time. You further narrow it down, and then eventually by $1 or even 1 cent every time, and you narrow it down. You find the exact answer. All right, so. Unfortunately, you don't have to do this, that way because you can use Excel solver. All right, so I hope this is useful.